Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Malfiyolla. ID number 251980112. I'm a student Master of Geography Education, Faculty of Social Science, Universitas Negeri Padang, semester July to December 2025. Today, I will present about the final exam inferential statistic, and the topic is GIS Statistic. Supporting lecture by Professor Dr. Dedi Hermon MP and Dr. Ahyuni ST MSI. Okay, let me start. Measurement scales in statistics. The first, nominal scale. This is a skill that is based solely on grouping or categorizing events or facts. When numerical notation is used, it does not indicate quantitative difference at all, but only qualitative differences. The second, ordinal scale. It is a measurement in which the scale used is arranged based on levels and a particular attribute so that the arrangement is arranged sequentially from lowest to highest according to a particular characteristic. But the order or rank between one and another does not have the same distance. And the third, it is a measurement scale where the distance between one level and another is the same. Therefore, the interval scale can also be called equal unit scale. And the fourth, ratio scale. It is a measurement scale that has an absolute zero value and have the same distance. Statistical data collection in GIS. Statistical data collection in GIS involves collecting spatial data and attributes relevant to geographic analysis with sources that can come from field surveying using GPS, satellite imagery, secondary data from government agencies, or existing database. Data source, primary data, field survey, using devices such as GPS or GNSS to record spatial data, coordinates, and attribute directly in the field. This data can include measurements, observation, and recordings. Remote sensing involves capturing raster data using satellite imagery or serial photography to produce consistent spatial data. Secondary data, data from government agencies, data from institutions such as the Central Statistics Agency (BPS), the National Disaster Management Agency (BNPB), or other research institutions. Databases and documents using existing data from previous studies or other documents. Open data, leveraging free data sources from various organizations through platforms like the Esri Open Data Hub. Presentation of statistical data. Presentation of GIS statistical data is done through spatial data visualization, such as thematic maps, graphs connected to geographic data, and tables, which aim to make the data easier to understanding and analyze. Map-based graphics, integrating statistical data into maps to visualize geographic relationship and patterns. And an example is a cartogram or bar chart placed over a geographic area to show statistical value. And then peta thematic displays statistical data visualized in map form. Example include population distribution maps, land use map, or flood risk maps. And then table presents statistical data in row and column format to display attribute data, descriptive information in detail. Table can be linked to feature on the maps for future analysis. And then statistical graphs. It's used standard chart types such as bar charts, line chart, or pie chart to display statistical data. But in a GIS context, the data is often connecting to geography information. Measure of central tendency in GIS statistic. A measure of central tendency in statistic in a single summary value that represents the center point or typical value of a data set. The three most commonly used measures are the mean, median, and mode. The first, mean, calculated by adding up all the values in a data set and dividing by the total number of those values. The mean is the most commonly used measure for normally distributed numerical data. Median, the value that is exactly in the middle of a dataset that has been sorted from smallest to largest. The median is useful when the data has extreme values, outliers, or the distribution is skewed asymmetrical. 3. Mode, the value that appear most frequently in a dataset. Model can be used for all types of data, including categorical data, and is particularly useful for identifying the most common category or value. Main measures of distribution in GIS. A measure of spread or variability in geographic information systems. GIS statistic is a metric used to describe how far spatial data values divide for their central value, such as the mean or median in a region. Range, the difference between the maximum and minimum values in a spatial dataset. This is the sample measure of variability. Interquartile range, IQR, the difference between the upper quartile, Q3, and the lower quartile, Q1. The IQR is often considered a better measure of dispersion than the range because it is less affected by outliers. Variance, the average of the squared deviation from the mean. That gives an idea of how spread out the data values are around the mean. Standard deviation, the square root of the variance. Standard deviation is the most commonly used measure because it has the same unit as the original data, making it easier to interpret. Coefficient of variation. Coefficient of variation, a relative measure of spread used to compare the variability between two or more datasets with different units. Basic concept of probability in GIS statistics. The basic concept of probability in statistics is used in geographic information systems GIS to analyze and model spatial phenomena that contain uncertainty. Probability is a value between 0 and 1 that indicate the likelihood of an event occurring. The basic concept include sample space, the set of all possible outcomes of an experiment of observation. Sample point, one of the possible outcomes in the sample space. Even, a collection of one or more specific outcome of an experiment. Conditional probability, the probability of an event occurring given another event occurring, which is often relevant in spatial analysis where event at one location depend on event at neighboring location. Probability distribution in GIS statistics. In geographic information system, GIS, probability distribution are fundamental because they help model, analyze, and quantify the essence, uncertainty, and variability of spatial data. Geographic data that has echolocation. They are used to understand pattern and make prediction based on location-specific data. 1. Normal Gaussian distribution, often used to model continuously varying natural phenomena such as elevation, temperature, or pollution concentration, especially in geostatistics. 2. Poisson distribution. This discrete distribution is dealt for modeling rare events that occur as point in space or time, such as a certain number of sharp per square kilometer or a volcanic eruption. 3. Binomial distribution. Use the model binary outcome, yes or no, present or absent at a given location. Inferential statistic in Geographic Information System (GIS) is the use statistic methods to analyze spatial data and draw conclusion or make prediction about larger population or processes based on sample of geographic data. Inferential statistic in Geographic Information System (GIS). The main goals of inferential statistic in the context of GIS are to testing spatial hypotheses, generalizing, predicting value or trends. The main inferential statistical methods applied in GIS include spatial t-test and spatial ANOVA, spatial autocorrelation, geostatistic, and spatial regression. Hypothesis testing in GIS. The primary goal of hypothesis testing in GIS is to determine whether observed spatial pattern or relationship in a sample of data occur by chance or reflect statistical significant processes or relationship in the broader population. Application example: point pattern analysis, testing whether the location of event, disease cases, business location are randomly distributed, clustered, or evenly distributed. Methods such as nearest neighbor analysis or the key function are used for the purpose. Spatial autocorrelation testing. Test whether the value of a variable at a location depends on the value at surrounding location. The presence of spatial depends. Moran's I test is often used the measuring the clustering of high or low values. Spatial relationship analysis, testing the relationship between two or more spatial data sets, for example, correcting air pollution levels which case in respiratory disease. Techniques such as spatial regression or overlay analysis are used to see if there is a significant geographic correlation. Normality tests in GIS. Normality tests in GIS are used to evaluate whether spatial data, such as population distribution, rainfall, or elevation, follows a normal distribution or not. Application in GIS, spatial analysis, normality tests can be applied to data used in various geostatistical models, such as spatial regression analyzing or disease distribution modeling. Testing data. Test data can be spatial attributes such as population density, temperature, rainfall, or pollution levels. 3. Model determination. The result of the normality test help determine whether a parametric statistical model such as regression can be used or whether a more appropriate non-parametric model should be chosen. Homogeneity test in GIS. The homogeneity test in GIS is a statistical test to determine whether two or more groups of spatial data have the same variant or not, which is often used as prerequisite before other statistical analysis, such as the independent t-test ANOVA 1, 2, 3. Example of application in GIS: air quality comparison, testing whether the air quality Variance in two or more cities shows homogeneity before conducting a comparative analysis of the average air quality in those cities. Demographic analysis comparing the distribution of demographic data from two or more residential area to ensure the variants are similar before applying future spatial analysis. Environment impact evaluation, comparing the variance of river pollution level downstream and upstream to ensure that the data variance at both locations have the same variance. Simple regression analysis in GIS statistic. The first, goal setting. Determine what phenomenon you want to explain or predict. Depend variable. The second, variable identification. Selecting independent or explanatory variable that theoretically or logically can influence the dependent variable. The third, model making. Using regression analysis tools in GIS software, which can visual data on a map and generate regression equation. And the last, model evaluation, using statistical diagnostics such as significance test, residual analysis, and classical assumption test to validate the model's accuracy and assure there is no significant spatial correlation in the residual. Multiple regression analysis. Multiple regression analysis is a statistical technique used to determine the influence of two or more independent variables on the dependent variable, function, and objectives. 1. Understanding relationship, analyzing and modeling linear relationship between multiple explanatory variables, independent variables, and one response variable, dependent variable. 2. Predicting value. Predicting the value of the dependent variable using the known values of the independent variables. 3. Measuring influence. Knowing how much influence each independent variable has on the dependent variable by giving different weight to each predictor. Path analysis in GIS statistic. Path analysis in GIS statistic is a development method of regression analysis to analyze causal relationship between spatial variables, such as the direct and indirect influence of one variable on another. Risk assessment analyze the direct and indirect influence of environment factor on the risk of an event, such as the influence of rainfall and slope gradient on the risk of landslide. Urban planning, modeling the impact of spatial planning policies on social and economic factors in urban areas, such as analyzing how infrastructure affect population mobility. Ecological analysis, understanding how variables such as land cover and population density directly and indirectly affect wildlife habitat. Resource management, analyze the direct and indirect impact and various variables on water quality or the sustainability of another natural resource. Analyzing of variance in GIS statistic. Analysis of variance ANOVA in Geographic Information System (GIS) is used to test whether the average difference phenomenon between region or group or location differs significantly based on the spatial attribute. Application is GIS environment science, comparing average air pollution levels across different industrial zones. Agriculture, Determine whether average yield differs significantly across fields with different soil type. Urban planning, analyzing whether average property values vary significantly between areas close to public facilities, school, park, and areas far from these facilities. Epidemiology tests whether the average incidence rate of a disease differs significantly between specific geographic area. Covariance analysis in GIS statistics. Analysis of covariance and ANCOVA in Geographic Information Systems (GIS Statistic) is a technique that combines the principle of ANOVA analyzing of variance and regression analysis with the aim of controlling for the influence of additional continuous variable to gain a more accurate understanding of spatial difference between groups of data. Basic concepts. Traditional ANCOVA. In general, statistic ANCOVA is used to determine whether there is a significant difference between the means of two or more independent groups on an independent variable, while statistical controlling for other numerical variables that might influence the outcome. In the context of GIS, geostatistic, in GIS, data is often spatial geography located and exhibits spatial autocorrelation, meaning values at one location are related to values at nearby location. Spatial covariance is a measure the extent to which value at two different locations change together, depending on the distance and direction separating those locations. Okay, that's all my presentation today. Please forgive me if I made any mistake during this presentation. And I hope this video can be useful for the other people. For the last one, thank you and see you.